So for describing distribution, so again, this is going to go on the top of in your notebook, on the top of whatever, however you're setting up. If you're doing 1 per page, 2 per page, probably 2 per pages. I wouldn't go any more than that. Displaying quantitative data. So when you're describing distributions, and that's what we were looking at, okay, you need to make sure that you use context. In fact, I will yell it right now. Use context. Okay. It's LY words. And then you also need to make sure that you have your shape, your outliers, which I think we're dealing with tomorrow. We're talking about variability tomorrow, or your next video. Center and variability. SOCV. Okay, so again, remember for shape, what's your skew? Is it skewed right, left, symmetric? And in terms of those LY words, you would say relatively symmetric because it can't, you're never going to know if it's exactly symmetric. So it's relatively skewed right, it's relatively symmetric, et cetera, because as soon as you don't use the LY word, then you're locking into that, and the LY gives us a little bit of wiggle room. Outliers, we're going to talk about later. For centers, either refer to your mean or your median. We know how to do that. And then variability, how spread out is your data? And that's usually done with the range at this point. Now, some of you may have come up with the idea, well, what happens if you have different, like, I mean, we had 2 different sizes of data sets there, right? So is the fact that students being really widespread out, but having more people there, different than having the teachers who didn't have as many data points and it was almost the same size? Okay. And then again, remember with these, compare, compare, compare. Okay. So what I would like you to do now is, we're going to take a look at this. So checking our understanding. So what percent of students, so here, 21 students, 20-point quiz. What percent of students scored higher than 16 points? That kind of gets into what we were talking about through a couple of days. So 16 points is from here on. So I've got, so we got what, out of 21. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I actually do this one, 21 minus 1, 2, 3, 4, so 17. So that's 81%. What's your shape of your distribution? So again, remember what size. So this seems to be kind of where the center would probably be. So the question is, this side over here is more skewed out. So that is more stretched out. So that's where the skew is happening. So we're going to say this is skewed left. Are there any potential outliers? Yeah, possibly. The score over here is 11. How do I know this is 11? Well, if I have this is 12 and this is 14, then it has to be 13. So the score of 11 may be an outlier. It's far lower than the rest of the data. Ta-da! So things like here, and again, we're going to write things in full sentences. But Mr. Hayes, this isn't an English class. Yeah, it's not actually a math class. It's a statistics class. A statistics class merges the two together. A lot of colleges now actually don't have stats in the math department. They have a statistics department separate from them, especially with big data coming in. All right. So for this last one, write a few sentences comparing the distributions of these. Okay, so again, you're going to go back up to here. You're going to have to talk about the shape, the outliers, the centers, the variability. That's just something that you're going to need. I mean, it's just going to get worked into your head, but you need to know that. And that's going to be the thing that and there will be a question probably based on something like this where you have to describe everything. And we're going to be describing how the data looks pretty much from now until August, from now until April. So you just need to make sure you hit it. Yes, you lose points if you don't. So here, shape, change up colors just for fun. So what's your shape? So the distribution of sentences, notice. The distributions of what? Resting heart rates, because these are 19 middle schools. What type of heart rate? Resting heart rate. There you go. That's important. Okay, context. So resting pulse rate. And after exercise are both skewed right. How do I know that? Well, I'll show you. If you turn it on the side, notice here, here's small to large, right? So your center, you've got this bunch up here and then it's being spread out here. If I do it the other way, notice I'm going from small to large. So this is basically flipped. So if you really wanted to, you could kind of hold it up like this, you know, like, all right, what do we got? But notice the numbers are both growing. The skew is happening on the numbers that are bigger than the others. So that's been what we do. Okay. They're both skewed right. Are they both skewed right? Yes. And in fact, we're going to even say this. They're both similarly skewed right because look, there's the biggest 1, 2, 3, 4 numbers, 4 sets of numbers there. So we're even going to say similarly. Are they both really skewed right, sort of skewed right, etc.? For your outliers, so your resting pulse rate, which one might be an outlier? That one. This one over here is probably over there. So again, for resting heart rate, (120) is a potential outlier. For after exercise, 146 is a potential outlier. Why are we saying potential? Because we don't know what the definition is yet. Again, notice here, labeled, nice key. Nice job. Which center do you think is higher? Now, we don't know the exact median or mode, or median or mean, but if you had to guess which one was higher, just by the data, not from using common sense, it would seem like this one's higher than this one. Why? Because all the data shifted up. So it's safe to say that the center and there's that descriptive word again, right, is higher. So for after exercise, than the center for before. That pulse rate there. And variability. So which one seems to have a higher variability? What's the range? What's the range? Okay. Variability for after exercise. It's a bit higher. with a range. So again, description, a bit higher, where is it, with a range 60 compared to compared to 52 for resting. Okay. So that's how we go through and describe and display quantitative data. So we'll talk to you soon, and we'll see what we can do to hopefully speed some of these up sometime. Make sure you check your notes. Shoot me an email if you get stuck.